the other thing, the other thing we want to talk about today is the spot detection or like the different type of cell detection algorithm. So when your type of image has a very weird shape of a cell, or in some scenarios where you have a very, very high resolution image, you don't want to use a spot detection algorithm because it will give you too much data or it will be less accurate. On an alternative method that ClearMap provides is to use an Ilastik segmentation classifier. So Ilastik is actually a name of a program it's a really sophisticated GUI where you can train a classifier to do a classification task. Typically, what we use it for is to classify a cell to a background. And you can train that classifier from like images that you have generated on your data, and you can make your own classifier and use that across your data set. Okay, I didn't share the screen. Yeah. So Elastic, you can go to the website of Elastic to see what it's like, and you can install and download it from these parts. When you when you open it, give me a second to open it. There you go. Yep. So it will give you a GUI like this, and you have a good amount of like options, but typically what you will do is use this pixel classification. Um, you will get this like space where you want to save your project. Um, I think I made something here. Uh, yep, there we go. So let's just save our crops here. So my project, so let's make it high res CFOS iDisco. Yeah, so let's make something like that. Okay, so you get something like this. So what you want to do is you want to feed in your cropped images that you generated through the script and use it as the training data set. Um, what I would recommend is don't make a classifier for one sample. You will get multiple crop images or test images from all of your samples, and then you can feed all of those images into the classifier. The good thing um, of our crop generation script is that what you will get something like this. In your folder, you will get two folders, a test folder and a train folder, right? So you get a test folder and a train folder. So what you want to do is use all the images that was generated into the train folder as a training data set and apply the classifier onto the test data set, right? Like that. So that will prevent you from overtraining your classifier to something that is specific to your data set, to your training data set. Like if your training data set does not represent your variable types of cells in your true data, you will be overtraining it to a specific type of cells, and your classifier will perform poorly on your true data set. So what that means is that you want to have a good amount of training data set, but you also want to have a good amount of test data set. You want to keep them separate, and then you want to make sure those are well representing your true data. Okay.
Okay,
Mhm.
so this means, okay, to do this, I would be in my variable file Excel sheet, and I would set detection flag as false, so I don't generate the detection flags, but I'll keep crop flag as true, and then I'll set a test proportion of some value to get the test files, and then I'll have the train files, which will be the number of n crops that I set. Is that
Exactly.
correct?
Exactly. So
Uh,
what you will typically want to do is first like open your experiment test data.
yeah.
So this will be fairly normal. You don't want to have anything change. For one thing is that this signal file range should be all. Don't change this to anything else for this purpose. And then for your variable file, you want to go to this crop generating parameters settings. There's two flags, crop flag and detection flag. The detection flag will be doing the detection part and validating your parameters or stuff. But you want to keep this false, and you only want the crop flag to be true. Typically, you want to have a good amount of crops, so maybe 10 will be too small. You want to maybe have like something like 25 or 50. If you separate the test proportion to 0.2, that will give you 10 test data sets and 40 um, training data sets in this case. That could be good. You can do like more like point 0.5 or something like that as well. And then the crop size can be fairly smaller. This depends on your image resolution. For your case specifically, you have a very high res image with very high resolution Z steps. So this can be definitely smaller. 100, 200, 200 is what I've been using for a 4 micron Z step, a 1.8 to 1.8. Sorry, 4 to 4 image resolution in XY, which is something that we get on the Smart SPIM 1.6 objective. So you can probably make this into 25, 50, or 50 like that. Okay.
Okay.
So you probably want to have like a lot more images. Maybe it can be smaller, but a lot more so that you don't miss weird positions, weird types of cells in your data.
Okay.
So for your specific case, I would rerun this and generate more crops if you feel like the test or the training dataset does not represent well your true dataset.
Okay.
One thing is that having total background images or having images that are from the edges of the brain, that is fine. That will give you a more of a negative control. So you don't
Mm.
want to have the edges to be falsely being positive cells. So those will serve as a good negative control. Okay. Once you generate crop images during with these parameters, you can I'll go back to these files, but you will get like folders like this in your on the cluster, and that will generate train images and test images. The first thing you will do when you start training these is to first of all download all of these locally. So make
Mm-hmm.
somewhere local like where you just download all the images from all of your subjects. And then you can just dump in these images in this input data tab. So now you can see that the 8 images that was generated through the crop is inside Ilastik, right?
Yep.
So just first of all, confirm that. You can also use Elastic provides very useful visualization approaches. You can go through the Z positions like this. This is
Mm-hmm.
the XY view. It also has projected ones. So now you're looking at the X-axis. Now you're looking at the Y-axis. So you can see the signals in um, free axes. You can also focus on Z alone by using some of these visualization tabs like that. Okay, the next part is this feature selection. This is generally what this is that it gives you options of filtering, specifically Gaussian filters. If you have a high signal to noise, such as CFOS signals, which typically you should, this shouldn't be very important. I will choose something like this one of a sigma value being 1 and use this. It typically doesn't get important if you have a very high signal to noise. So the most important part is this training. So in this training, you start to give labels to your images of what is a cell and what is not, what is background. Okay. The most important thing is that you want to be you don't want to mix up the label 1 and label 2. So I'll give something like a name, cell, and background, something like that. Okay. One important thing is that the classifier, when ClearMap reads the Elastic classifier, it doesn't read the name. it reads which one of the labels listed are the ones that they want to focus on, or like in this case, which one is the cell. If the first, so I recommend to have the first one as cell. If you look carefully inside um, the variable file, in here, elastic parameter, there's a thing called class index that is specifying which of the labels that you want to use. 0 means the first one, 1 will be the second one. So if you mess up and you put cells in the second label, you can come here and change it. But I would recommend having the first one as cells. Okay. Now you got the cells and the background. You can start labeling them. So, so for example, I want this to be a cell, which I truly believe this is a cell. Nice. I would get this. I will use this pen or like brush icon and then use the smallest size, size 1, and start painting the areas that I think will be a cell. Yeah, you can hide the labels by using this part. So you can like turn it on and off. You can also do the same thing from different axes. So if you want to say, okay, this looks like a cell, I would say, okay, I'll also paint this like that, right?
Do you want it to be when you paint it, do you always want it to be basically kind of spherical or should it be long
It
too?
does
Like for
it,
example, that
it
one looks like it might be kind of long.
so it doesn't have to be. It can be any shape. I would just paint wherever you think it is a cell. So that is a totally separate conversation or question. How does an experimenter define a cell? Because you cannot go away from that question when you do something like this. The classifier will only be reflecting what the experimenter thought was a cell.
Okay.
So if you have a more ambiguous, if your images are more ambiguous and you can't define what a cell is, you shouldn't be doing this part yet anyways, or like any kind of spot detection part anyways. You at least have a ground foundation or like at least a belief of what you think a cell is and don't like move around from that.
Um, and you have to cover multiple pixels here. You can't just like put a dot on it like if as if it was spot detection. You can't just click a dot on every cell.
No, I won't do that. So
Okay.
later on, the classifier will tell you where the center of that cell is as a spot,
Okay.
as a
Okay.
dot. But in this scenario, what it's trying to do is to identify which pixel in this image is more likely to be a cell or it
Hmm.
likely to be a background.
Yeah,
Afterwards, they will use this like um it will what this will do, it will generate a probability matrix, which every pixel will have a probability to be 99% a cell or like 5% a cell or something
I
like that.
see.
And then
Yeah.
using that, they will make the second algorithm will identify what part of these groups of probabilities be a cell or not. And then from there, they will create a mask, and then ultimately they will identify the center of mass of that mask is and then give you back a coordinate of each cell. So, okay, so another important thing is background. What I typically like to do is go very close to the cell because that's generally where there's the highest intensity of the background. So this is very likely to be a background, but it also has somewhat high signal intensity. You can also go to areas like think areas like this are more likely to be a background. You can go have a more like larger brush and just like cover spaces like this. Um, I would typically recommend not focusing on this too much. Typically do 1, 2 cells per stack. And one Z position or 2 Z positions would be good enough. So like something like this would be fine. And then let's just try to do this cell too. Yeah, that should be fine.
When
Okay.
you say 1 to 2 cells per stack, are you talking about the Z position or is
No,
that different?
it's different. It's like just like a cell, like anything, a cell. Like I think for me this looks like a cell, this looks like a cell, so like two
Uh-huh.
cells. But this doesn't have to be, you can do more. It's just like as for efficiency.
Okay, yeah.
So what ultimately Elastic does is that if you press this live update button, it will reflect what it will generate a classifier and report what the classifier thinks is a cell or not based on all the information you provided. So
Hmm.
now you can vaguely see the prediction of a cell being overlaid onto the image, right? So
Yeah.
if we put this label part hidden, you can see this like gently yellowly labeled parts and gently blue labeled parts. Those are the prediction for cells. Like for example, if I turn this off, you don't see that anymore. If I turn this off, you don't see the prediction of background anymore.
Hmm.
So you start to see it's doing a good job to identify bright cells, but you probably want to do a little bit more like dimmer cells
Hmm.
to make it more consistent. So like for example, let's just focus on this one. Yeah, so let's probably focus on this one. Another thing that you can do is if you press this button, this will change the level of intensity.
I see.
So yeah, actually, like, I think, yeah, it, it changes the brightness or like the thresholding part. So
Hmm.
this is another way you can like further like if make things efficient. But again, I want to think that this is a cell. Oh, yeah. And then I want to think this is a background. I want to think this is a background. I want to think this is a cell. Let's go to a different position. Yeah, I think this is a cell. I think actually this is a cell too. Actually, no. Let's erase this. I think this is a cell. And I think there's two cells here. Yep. And then if you click live update again, now it will
Mm.
update your
Wow.
resolution and give you something like this.
Yeah.
So you can keep on doing this to all the images. So if you look at here, there's this current view. You can go
Yes.
to your next image and go to the next image. Let's actually go to something that doesn't look bad, doesn't look good. Yes, for example, this one, this is the border. So I don't want these bright places to be a cell. So
Ah, I see. Okay.
I'm gonna use all of this to be background. I don't want this to be cells. I want to be this to be background. So this is also something you could do. Okay.
Yeah.
So what you do is you keep on doing this to all the images until you're satisfied. And you should constantly click live update. If you keep this on forever, for all the time, it does use up some of your computation power, so it could get slower. In that case, just turn it on, turn it off, turn it on, turn it off, okay?
Hmm.
But you can just do that and and see, go through all the images and make sure that whatever you see is reflecting your belief of what a cell is, okay?
Yeah.
Until you're confident enough.
Yeah.
So once you do everything of that, um, you can actually um, save the project. Okay, the classifier itself will be saved inside the project file. So here you go. So inside the ILP file,
Yeah.
make sure to live update actually. That's very important. And then you can actually close it. Yep. So now you have this like now this classifier is just 407 kilobytes or
I
something like
should
that.
live update before I save, is what you're saying, or before I
Yes,
close it?
it doesn't have to be like on or off, but live update is the only timing where it regenerates the classifier.
I see. Okay.
So if you train a bunch but don't press a live update, it will not save the latest classifier. It will not make the latest classifier, thus it won't be saved.
Got it.
So now this is generated. What you want to do is actually, let me just clean this up a bit. Nah, I don't know. Nah, never mind. So the next thing you want to do is you want to upload your classifier. Oh, this is so nice. Okay. I have this
Wait,
like I have this previous one that has a very similar name. That is so
oh,
not good.
I have a quick
Um,
question.
mhm.
So that classifier, what I would do is actually I would take the cropped images from all of my brains and put it in Elastic in one sitting, and then basically classify a few cells from each single from every cropped image from every single brain to create one single classifier.
That is what I recommend. I would say in cases, especially when you get to the later part of the classification or the training, the classifier is doing so well. It doesn't need too much more new information. So, and in that case, you probably don't need to add more labels. So there may be a point that you don't think you need to do any new labeling to the images. But typically you will do like one to a label per 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 crop and then go through all the crops from all the brains and generate one big classifier that you can apply for everything. Okay.
Okay.
Um, yep. Okay, so okay.
Sorry, another quick question.
Mhm.
I will be generating a whole nother set of around 23, 25 brains actually. Um, I'll do a whole separate iDisco and a whole separate staining, assuming I'm doing everything. But there's going to be, variance between the two clearing and staining protocols. Would you recommend that I basically, when it comes time to do that, I regenerate a whole new classifier for all?
That's actually a great question. So I think there's multiple approaches. What you're trying to say is that should you make a classifier specific to a batch,
Yeah,
right? Um, my thought process is that ideally you shouldn't, but there are cases that you have to. Um, in in other scenarios, you probably want to um in an ideal scenario, you want to like wait till you collect all of your data. If everything looks similar, make a classifier using all of the images and then
yeah.
do that.
Okay.
Realistically, you don't want to just be sitting there doing nothing for another month or two.
Yeah.
So, uh, what I would do, so the way I think is that ultimately this comes down to you need a way to validate your classifier.
Yeah.
And then if the validation tells you that the classifier is doing a equal good job across the two batches, it's great.
Yeah.
Even if you have two separate classifiers, if the results of that classifier is similar across the two batches, I think that's also fine, right?
Yeah. Yeah.
So it really comes down, you want to have at least a good enough way to compare the results of the classification across the batches.
Okay.
Right.
Yeah, that makes sense. Just basically due
Yes.
diligence to
Yes.
make sure we're not doing some
Yeah.
weird predictions.
The
Okay.
way you should do that is to have some blind experimenter to manually count the cells in those test crop data sets and compare what you extract from the Elastic process for ClearMap and compare it with your manual results.
Okay.
What you will get is that, so like manual counting is a different thing. I think there's other approaches, but you can like just say this is a cell, this is not a cell, and record the coordinates of those cells. And then that will be similar to the results you will get through ClearMap. And
Hmm.
if you can say that, okay, in in these two approaches, this cell was counted same in both ways. This cell was only counted in manual, but not in ClearMap. This cell was counted in ClearMap and not in manual. You'll get that information if you have two separate lists of cells that you think is a cell from the two approaches. From that, you will be able to generate something like a false positive rate, a false negative rate, right? A false positive rate will be the amount of cells that was counted in ClearMap but not in the manual. The false negative rate will be the cells that was counted in the manual but not in ClearMap. Using those metrics, ultimately you can calculate something called an F1 score that reflects both positive and negative, false positive and negative rates. That will be, I think, a good metrics to quantify your performance of classifier, right?
Okay.
So say you have a 70%, a 0.7 F1 score from this classifier. What you can do is to apply the same classifier to your next batch and just test if the F1 score for the new data set is similar to the F1 score that you generate in the previous data set. If it's
Okay, yeah, that makes sense.
if it's very similar, you can say, yes, we can just apply this classifier across subsamples. I think that's fine.
Yeah,
If it doesn't, you maybe want to retrain a classifier.
that makes sense.
What you don't want to do is you don't want to compare results coming from a F1 score that's 90% and the F1 score that's 70%, right? So another thing you want to do is make sure that maybe it will be post hoc, but just make sure that the two classifiers are performing in the same rate. And that can be quantified using the F1 score.
Okay.
Ultimately, I don't think there's a correct way to do it, but at least having
Yeah.
some like value that can like prove that the classification is not too different from the two batches is important to assure that you're doing something correctly.
Yeah. I mean, you could also just update the classify, right? You could bring
Yes,
in the second batch and
yes,
then just update it with that. So it's
yes,
you don't have to redo everything. You can, okay.
yes. Making a classifier perform completely differently later on could be challenging because it's so well trained on an existing data set. And if the new data is totally different, it doesn't like easily overwrite the previous algorithm. So maybe it will be easier for you to just retrain a new one. That's like just case by
Okay.
case. Depends on how different the
Okay.
two batches are. Um, but I'll keep that in mind. Just like
Okay.
those are the things I would think about.
Okay.
Okay.
Got it.
So yep. So yeah, that totally an issue about like a trained classifier. If it's like an untrained, unsupervised classifier, you don't have to worry about this. But unfortunately, that's not the case. Okay, going back to what you should do on the cluster is that so you generate this like ILPF file that has a classifier. You send that to the cluster. So now you have this high-res C plus I disco ILP file here, right? So that's the one that I previously generated, but I just transferred to the cluster. Inside these variable files, oh, I actually had it open all the time. So inside this variable file, there's this tab elastic parameter. You will
Hmm.
have all this, you will make the pipeline use the variables that is listed here to do the elastic process. The first part here is telling where the ILP file is. So you just basically want to take the path of this, copy to clipboard, and then you can paste it here. Oh, wait. No, that's the wrong file. Just take this one here and paste it here. Okay. And then class index I already explained. If the
Hmm.
first label is cell, use 0. If the second label is cell, use 1, so on. Okay, and then you don't have to worry about this spot detection part. That's completely gonna be ignored because you're using Elastic. Just need to change these two. Okay,
How
another
did you indicate in the variable file that we're not doing spot detection, but we're doing elastic instead?
great point. So the next thing you want to change is this experiment parameter code.
Oh, okay.
So in here, there's this image processing method, and it says Elastic. This was spot detection as default. You want to change
Hmm.
that to capital I Elastic.
Uh-huh.
With this flag, the program will identify, oh, okay, we need to start using Elastic, and it will start using Elastic. So change this, okay?
Okay.
And then Okay. And also, just to make things clear for you, let's also change this one. Inside here, now in the generating parameter, you don't want the crop flag. You want this to be false. And then you want to have this detection flag to be true. And
Okay.
then you can keep running this one. Okay.
Because those are going to be ignored now, because they're not cropping.
Yeah.
Okay. So those are the only two tabs I need to change in the variable file is the elastic parameters and also the crop generating parameter.
Yes, so if you want to start doing the detection, yes, you want to change this flag to be true, right? Because now
Yeah.
you don't need to crop images, you want to only do the detection. And
Yeah.
then this will be true not only during the detection validation step, but when you also want to do the um, on the full data set, you
Mm-hmm.
want to make sure that this is specifying the path to your
Yeah.
Elastic classifier and also the experiment parameter file also is specifying the Elastic flag, not the spot detection flag.
Okay.
Okay, so once that's done, you can do the same thing, run the batch submit detection validation jobs, and you will just get a bunch of validations. And then inside your file, for example, in my file, it will give you all these like images.
Mm-hmm.
This is currently saying spot, but this should be elastic. So instead of having this spot cells check, it will be elastic cells check.
Mm-hmm.
Yeah, but you will have the exact same type of images and you can download that and check that.
Okay, but I won't have uh
You,
so I won't have files that have the crops though, right? I'll just have the check files, the cells check files. I won't have the the TIFFs that are like the Z stack of the crop.
yes.
Is that
So
correct?
so these ones, the ones that I'm just pointing to right now, these
Yeah.
ones were the original cropped images.
Yeah.
So those will be used to test the classifier, and then each file will have the results file saved as well, and these will be the results files.
Okay.
So like if you have like 20 images here, you will have 20 images, 20 files of that says image name one, elastic cells check TIFF, image name one, elastic unfiltered cells check TIFF, and those will be reflecting the results of elastic. Uh,
What's the difference between the unfiltered cells and the cells
that's a
check?
great question. So this is a common thing between elastic and spot detection. But the way the pipeline is constructed is that it will first give a pass to a lot of candidates, and it will further threshold them based on different parameters that you gave, right? That parameters will be is can be found in the variable file. And that's actually a very important point that I want to touch next. Okay. So here, if you look at this, there will be a threshold parameter section. So inside here, there's this very simple two columns, threshold and row. These two indicate um, some ways to threshold your data. The way you want to think about it is that you have tons of candidates that it can be a cell. Um, it could be a very, very teeny tiny artifact or like a very, very big one. That's also could be an artifact. It could be too bright to be a cell. It could be too dim to be a cell. But you want to like filter those out after you get the candidates. Realistically, in an ideal scenario, if you train a classifier well enough, you don't have to do this, right?
Yeah.
But in very commonly, there will be like small artifacts like on the edge or where else, or on the edge or like on the edges to the ventricles and things like that. That is just
Mhm.
very bright, but just very artificial.
Yeah.
That could be filtered out by size or like intensity. And this is the part where which allows you to do that. The way it's written is it's very confusing, but the row will indicate what type of parameter that you want to use, and the threshold will give you how you want to threshold it. In the elastic part, you will have two options. The size and the intensity. Sorry, intensity and size. Well, intensity and size. Intensity will be identified by 0, 0, and size will be identified by 1, 1. That's just how the code is written. Um, so what this will mean, so for example, what this will mean is that intensity under 20 or over 50,000 will be omitted. And size under 50 and over 5,000 will be omitted. That's what it's selling. Okay.
Okay.
If you're going to do an elastic part, I would only use size. So I will only use size like that. And then I will give it a very low threshold and a very large upper threshold, something like that.
This is what you would recommend kind of as a default for Elastic for the FOSS stuff we're
Yes,
doing?
for right now. Just
Okay.
obviously check it with your
Yeah.
results. But this will what I would start. Elastic is very good at getting rid of big ones, but I think
Yeah.
it does sometimes fail in getting the small ones out. So this
Okay.
what I would recommend. Being more specific. Okay, so what there's are typical scenarios that you will see. You will see a bunch of spots in the unfiltered cells, but no spots in the cells checked TIFF, right? In that scenario, what's happening is that you're filtering too much, right?
Okay.
Because you have a bunch of candidates, but have nothing at the very end.
I see.
So
Okay.
you probably want to loosen your thresholding.
Okay.
If you don't see anything in unfiltered, and if you don't see anything in the filtered ones as well, that's just bad classification. You don't have any candidates, you don't have anything at the very end. In that case, you'll go back to the classifier and retrain it. Okay.
So ideally what we see in the unfiltered is a lot of great cells and maybe some artifacts or any artifacts. Maybe the classifier works so well there are no artifacts, but let's say there's just a few artifacts. And then what I see in the cells check is that those artifacts are now gone.
That's the ideal scenario. That's what you want to
Okay.
go for. Yes.
Okay.
In a realistic world, it could be difficult. I think ultimately people have to make a decision of just you have to omit some dim cells. You have to omit
Yeah.
some other cells. I think that's just the restriction we have currently because
Okay.
we have to apply basically a very you basically have to apply a classification strategy universally to the brain, which may not be which could be untrue sometimes. But
Right.
that's just what the limitations are right now. But you want to just get the most out of it. A very critical point is that you have enough tests or trained images that well represents your data. You don't want to commit, you don't want to have images coming from small sections of the brain. So like more images will be better, more smaller crops will be better. It will take more time to train because of how much images you have to go through, but typically that will give you better results.
Okay.
Okay. So I think that's it. And then once you're satisfied with the classifier, you can go to the next stage. You just have to yeah, you just have to make sure that you re-changed some of the parameters that we just went through. But everything else should be identical as the way you've been doing it. Okay.
Okay.
So I hope